I'm Serafin, and I'm a robotics engineer. I've been working in the field for around 5-6 years right now. I've been working in a few companies here in Krakow. Also, I spent some time in Japan. Currently, I am working in a company called Luxanis. I will talk a little bit about that. I will do some shameless product placement, but it will come later. Yeah, I would like to. Yeah, this presentation also contains some. I would say, well, it wouldn't be a tech presentation without some funny animal pictures. So, but this time it's with a twist. These images were generated by neural networks, so it's never before seen cats and dogs you will find here. And when it comes to the presentation, I don't know how many of you are into the world of robotics. Maybe you could raise a hand if you are developing some code on the robots. Okay, maybe you're a student and you study some sorts of mechatronics course. Automation. Yeah, okay. Yeah, this is good. I was afraid that I will be in a room full of robotics engineers and I would have nothing worthy to say. So I would like to discuss a few questions. We will talk about what's a robot, what components make a robot, what kinds of robots you can meet out there in the wild, whether you should buy or make one yourself, how to make a program, and where to learn, where to start if you want to get into the world of robotics. There will be no math, nothing serious like that. I would just show you some kinds of examples. Okay, so here we go. Well, first I would like to ask you a question. You're all probably familiar, unless you've been living under a rock, with smartphones and coffee makers. And my question for you is that, would you consider such devices a robot or not? And why not? Would you consider a smartphone a robot?
Have motors, have sensors.
It has to be autonomous, no?
It doesn't move, so no. Have moving parts, have motors.
Okay, how about the coffee machine?
Also have sensors, have moving parts, have some control.
Yeah.
Needs to be operated by humans. Oh.
And be in cooperation.
Yeah, these are good answers because, to be honest, it was kind of deceptive. The answer is not so clear. But for this presentation, I would like to pose a few, I would say, rules of what we will be talking. So I assume that the robot is a machine which is programmable. It interacts with the real world via actuators or some other devices. So you could consider that smartphone has physical buttons, but it doesn't have an actuator. You cannot run wheels or something like that. And it can perform different tasks depending on programming. And while a coffee machine can make you different kinds of coffee, it cannot make you a pancake, for example. So I think 3 words describe perfectly what robots are. And these are sense, think, and act. And when we are talking about these words, we can split robotic hardware into several different components. When it comes to sensing, robot can gather information about its world from a number of different ways. Some would be cameras, some would be lidars. We could have some temperature sensors, some, pressure, GPS, all sorts of things. Radiation. Robot has to process this data. So it has to have some sorts of computer, which could be a laptop or a Raspberry, some industrial computer, or even Arduino or some other microcontroller. And then to act, to interact with the real world, it needs to implement some some sort of actuation device which could be powered by hydraulics, pneumatics. There could be all numbers of electrical motors. I also added some lights here because this is also a way that robot can alter its environment. We will have, I wanted to show a little demo here. It's a little bit hard to navigate. I have brought here two sensors. One is a LiDAR. Here. And let me change. Can you see those red dots? I'm not sure. I'll just change. Oh. Yeah. So, here is a small device which has a laser sensor on it, and it rotates around 360 degrees, and while doing so it maps the whole area. And this can be used, this is very popular in autonomous vehicles, and well, there are more expensive sensors that can map environment in 3D, but if you want to start making autonomous robots, you can start with a simple 2D LiDAR like that. Another sensor that I brought, and yeah, this is the shameless advertisement. I've been checking it out here. So you can see that it's a little bit dark here, but we can just project some dots and make the environment a little bit lighter. So the camera can see more in the distance. It can also process some depth information, so you can see how the depth looks. Yeah, you can see here the pixel values represent the closeness, I would say, of how close am I to the sensor.
This is one of the OBD cameras?
Yes, yes. This is OBD Pro. We have several different cameras, depending on the type that you want. They really come like wide angle, wide FOV, a lot of FPS. I mean, depending on what you need. I am currently responsible for writing software for robot operating system drivers for this camera.
Eventually.
Eventually, yeah. Well, let's go further. What kind of robots are there? And I mean, there are a lot of robots, but I decided to split them into 4 groups, so it's easy to talk about them, and based on what they do, how they perform, what environments they are in, you can distinguish them. So the most common type is industrial robots. So these are the robots that you can find in factories. Tending to the assembly lines, they perform boring tasks like assembly, pick and place. You can have different configurations, kinematic configurations for each robot, which means that you can see that in the picture above, here is what's called a delta robot, and you can see that here is a more classic manipulator. One word comes up with when talking about industrial robots, it's a cobot, and you can see an example of the cobot here, and it's an industrial robot which in theory won't tear out your arm or won't hurt you, but yeah, if you can attach a knife to it, things may happen. But yeah, if it hits you, it has some brakes, so it won't like go through you like a normal industrial robot. I don't know if you've seen some like industrial robot crashes or something like that. It can be very scary. Yeah, another types are mobile robots, which can be wheeled or legged. You can see an example here of a robot from Husarian, which is sponsoring our view today. It's a new type of robot that they developed here in Krakow. Below you can see Animal, which was developed on Zurich University. And you might have probably also seen some videos from Boston Dynamics. They are like the most, I would say, popular company right now. And when it comes to mobile robots, you can also upgrade them. You can mount an industrial arm on such a robot so it can perform different tasks and it can go from one place to another and, for example, operate some machine via teleoperation.
Right behind you, there is an example, like over here. Oh, on the roll-up.
Yeah.
I was afraid it was here.
Waiting for me. For such a robot to orient itself in the environment, we have to use what's called SLAM, which is simultaneous localization and mapping. So in basics, the robot, based on the sensor data, can orient itself by using, for example, such a LiDAR or 3D camera and know where is it in one place. Other types I think you're all familiar with are drones and aerial robots. So these are, like, I think the most available to ordinary person, since you can buy it off the shelf I don't know, in any electronics shop. And some of them are programmable, some of them are just for making movies or something like that. And they can be used, for example, in search and rescue missions or to map the terrain, for some geological research. And we're gonna probably talk in the future talks more about these kinds of robots. Also, the last type I would call are underwater robots. So this is, I would say, extremely demanding environment, since you have electronics and water do not really like each other. So you have to, when designing such robots, you have to take into account the water pressure, all the different sensors that you need to have, because you need to use acoustics, for example, to orient such robots in the environment. And most of the companies currently are using such robots for maintenance and for ecological research.
A casual look and a quick listen, and you'd think this is a pretty affectionate kitty. This is actually an amazingly realistic robot. The kitty purrs, blinks, rubs its face, and even rolls over. But that's not the most remarkable part. It's the effect this robotic pet has on the residents in the memory care unit at the Hebrew home in Riverdale. All of these folks have varying degrees of Alzheimer's or other dementias.
Makes me happy. I'm very happy. She talks to me. That was a long conversation.
Nancy Trainellis is Justina Lekenfora's daughter. She's not sure whether her mother knows the cat is real or not, but she does know that it has a calming effect on her mom.
With this, I don't see that agitation. She smiles and wants to talk. So content.
Hebrew Home CEO Daniel Weingold says they already had a pet therapy program, but live animals need feeding and cleaning and aren't always around when residents need calming. And the robots give residents something else important.
Even provides an opportunity for the resident to be in the role of the nurturer and the caregiver, which is a very common kind of experience for that.
Dementia patients can sometimes become agitated and hard to soothe. The robotic cats do that without drugs.
These animals are a wonderful way to use a non-pharmacologic approach to offer comfort and a sense of calm.
And you only have to watch the residents interact with the pets to see the beneficial effect.
It makes me happy.
And if you doubt that the robots are realistic, here's one the newsroom has adopted, and
Yeah. Okay, one more movie. Oh, this one's nice. Yeah, so as you can see, well, there are robots that can be used in, I would say, they're sorts of universal for different use cases. There can be also robots that serve purposes which are more for the social needs of a person than just perform tasks and do your job and don't talk. Okay, so here I made a little slide because I'm not sure. Sometimes when I talk to people, we are missing the scale of what a robot can cost. So if you want to get started in robotics, you can get started from around $300. And while these can be toy-like and they can be not as rugged or maybe 3D printed, lesser quality, they can still be developed and used as a bigger robot which is more performant, has better specs, could be. We can program such robots. I've made some, I've chosen some robots. I also did another shameless plug here on the left side. Yeah, we launched a Kickstarter, so one of those robots you can back on Kickstarter, and it's gonna provide all the bells and whistles of a regular robot. You can start practicing with it. When it comes to robots above $1,000, I'd say 1,000 to 1,000 range, and these are still what I would consider robots that are used mostly for education purposes and for testing of algorithms. But above $10,000, we're getting into the territory of some real robots. You could buy an industrial robots in this price range. You can buy one of those robots that you can see in Carrefour robots. It's around $20,000 or $30,000. I don't remember correctly.
20.
Yeah, or you can rent it.
Yeah.
Yeah, and this is like the range that I would say most professional robotics resides. And above $50,000, you can see that there are more specialized equipment and there are more specialized robots. And yeah, you can buy a spot from Boston Dynamics. I think it's around $80,000 currently. Same for the KUKA here. And because they use more sophisticated control algorithms, they are a bit pricier. And yeah, this leads us to the next step. What are the biggest factors when it comes to the robotics? Well, the main factors are what materials do we use? Do we use 3D printing? Do we machine the parts for the robot ourselves? how precise is the machining process, what kind of motors do we have, how strong are they, what motor controllers are there in a robot, what sensors can be put on the robot, because sometimes if you put a sensor on a robot, the price goes, the price of a robot is twice the original price, depending on what you put there. And there are also some development costs which can be mitigated. Recently, there's some pursuit in open source when it comes to the robotics. Yeah, so now if you decide that these prices are too much for you, you can build your own robot if you really want to. You need only some particular set of skills, I would say. It mostly comes to software engineering, mechanical engineering, electronic engineering, a lot of maths, and this can be a little overwhelming for someone who wants to start their journey with robots. But yeah, you can start with a simpler approach, and I hope that I will show you, based on some examples, how development of such a robot could look like. This is an image from an open source project. It's called the Rosbat. You can find it on GitHub, and it has all the materials listed for it and all the code that you need to run it. So the main components when it comes to physical robot, I would say, would be the chassis, which is the main body of a robot, where you put all the very expensive or not equipment. You also need to have a battery, so the robot can power itself on and perform tasks. You need a computer, which can be a Raspberry Pi, it can be an Arduino, that depends on what you want to do with the robot, how much power do you want to give it. You need to actuate the robot, so you need motors, wheels, drivers, and decoders for those motors. And you need a sensor for a robot, so it can interact with the real world, as we've said before. And yeah, what's gonna happen? Like, we assemble the robot, it's standing right in front of us, and how can we turn it on? How can we, I would say, connect all the parts so the robot knows that it has motors, it can move, it can sense. You can do that by writing some drivers for the devices that you have, or using the ones that are already made. So a driver is a program that talks to the device, and depending on what the device is, it presents you with some functions, APIs, to work with that. So for example, we can set the motor position or get the temperature reading. Yeah. When it comes to the programming languages, I would say, if you're on the university here in Krakow, in IGH, you're probably familiar with MATLAB. And this is, I would say, a controversial topic, but I would say that MATLAB is a good place to start when it comes to the theory behind robotics, because the documentation is very nice, and there are a lot of functions. But if you want to make a robotic startup and you start to buy licenses for MATLAB, well, it's gonna take you some money. So another way would be to choose one of the programming languages and develop your own application, your own software stack. And you can do it in, I would say, any language. C, C++, Python, Rust are the most popular, I would say, when it comes to working with hardware. Also Go. Yeah. I decided to show you some pseudocode. It's based on Python. it contains all the like information that I wanted to present. So let's say we did connect some motors to our robot, and we want to move it. So we write a program, I would say, code snippet for motor controller. So it has some functions for connecting to the device, for reading and sending data. So you can send velocity information, how fast the motors would need to move. You can read the encoders to get the robot position and then calculate where the robot is based on that position. And another example would be same device driver for a camera. So you connect to the device, get images. You can do also some sort of processing on those images. And yeah, based on my experiences on the university, I don't know if it has changed, but most of the programs that we've written were in a single file. When everything is put together, the program has like 2,000 lines of code. And yeah, but it's working for us. So yeah, we need to just have some logic loop. We move the robot a little bit. We get the image, we calculate the odometry, we get some rough idea of where the robot is and what is it looking at, and yeah, we can do some more and more logic. And this can be, while easy at start, it might be hard if you want to make some advanced logic, or if you want to take capabilities that some of the sensors might work a lot faster than the others, and you'll probably get some hardware errors, because there's always some hardware errors that are unexpected and break your whole program. Yes?
Can I ask a question? Can we start with simulation?
Yes, we can start, but when developing code for the simulation, we also have to take into account that we need to have some sort of simulated robot and add some sensors for such a robot. So there are some simulations, I might talk a little bit about that provide some solutions out of the box for robots. It's still, you could still do that in simulation, like put the whole code in one line. If you're patient enough, it would work. But another way, and it's very popular in IoT, and I think in web services, is to separate the programs by function and use some kind of a communication protocol between those programs to send and receive messages between them. I don't know, microservices come, I think, to mind. I'm not a web developer, so I might be going a little bit ahead, but yeah. And this way we can separate the logic that only concerns this motor controller, and it can be encapsulated inside this program. It doesn't need to know that the camera broke and the whole program is doing different stuff. Only this robot needs to know it. And it doesn't need to know like little implementation details on what the robot, what the motors are doing. It just needs some basic information from this. Okay, so what's very popular in the recent years is something that's called robot operating system. The name is a little bit misleading because it's not an operating system, I would say, in a classical way. It's more of a framework, and it provides a way to have that kind of encapsulation. So you can have a program which represents a camera driver or driver for some force sensors, and you can use those messages because they are defined already within the ecosystem. So you can use the image, for example, message, and you can expect that if you connect a different camera, it's still gonna be an image message that you receive. And there are also some open source libraries for it. And how to use it? Well, first of all, I would recommend that you get Linux. You could also try on Windows, but I think you're gonna have some trouble with that, based on my experience, though I've been working on Windows a few years ago. And the main languages that you develop in are C++ and Python, depending on it really, the way that most of the software is done is you first write the program in Python and then you rewrite it in C++, so you enjoy the same API, but you get better speed using C++.
Twice.
Yeah. Okay, I have a very small example here. So, I'll hide it a little bit. I don't know if you can see here, or yeah, I'll post it. So here I am launching from the terminal browse node, and it's a very simple node. It just puts out string, hello world, and an integer out to the, I would say, network. And that image can be subscribed to, very similar to some frameworks, some frameworks like MQTT. So you can run another program, and yeah, this could be a sensor data, image, motor position, whatever, and this could be a robot control program. And it gets the message, and based on that message it can perform some data. And there are some tools in Rust that you can use to show. How the interface, I mean, it's a very simple because we only have two programs. So we have a attacker program, and it outputs on the chatter topic this kind of data, and the listener subscribes to it. And while the idea is simple, the example is simple, if you build a large software enough, you will see a lot of spaghetti here. Like if you add some open source libraries, it's gonna be like, it won't fit on the screen probably. Yeah, the same, like the example with a LiDAR that I showed earlier was the same principle. There is a program for the LiDAR which outputs data on the laser scan topic, which then can be subscribed to and worked to get map of the environment, for example. Yeah, there are two main libraries when we're talking about ROS that are the most popular, and I think these are the reasons why people use ROS. And one of them is navigation package, which provides path planning, collision avoidance, localization functionalities for mobile robots. And this can be used both in simulation and on a real robot as well, so you can test out your algorithms. Yeah. Here we have a small robot. It also has a LiDAR on itself, and this is the map of the room that is created based on LiDAR points. Yeah, and all the algorithms that are implemented are open source. You can look up, you can make adjustments or create new ones. They're also customizable, so you can tinker with the values that you have. You can add all sorts of different sensors that you have. And when you have such a robot representation, you can just add some external sensors, and for example, if a 3D camera detects a person, you can just point it at the map where that. Here we go.
Yes. The
Sorry,
open source robotics platform for building commercial manipulation applications. MoveIt combines advanced kinematics, motion planning, and collision checking capabilities to plan and execute optimal motions for any robot manipulator. MoveIt is robot agnostic and has been used by hundreds of large corporations, startups, and research labs to develop custom automation solutions. Because of its academic roots, it brings cutting-edge algorithms to reality. Integrate your robot to use MoveIt with the Setup Assistant, a simple user interface for configuring MoveIt to work in any robot environment. You provide the robot model in URDF format from your favorite CAD program, and the assistant takes care of the rest. After completing setup with the Setup Assistant, you can out-of-the-box start exploring MoveIt's capabilities in RViz using the easy-to-use motion planning user interface. Immediately test out various planning algorithms, workspace layouts, and optimality trade-offs. Planning scenes of obstacles and other environmental details can be created, saved, and loaded from file for easy development and testing. A robot's wheeled base can also be controlled by MoveIt, allowing for complete mobile manipulation solutions. You can control various subsystems of the robot, or all joints at once. The ability to preview an automatically generated path.
Okay, so as you can see, this is more for setting up new robots that use, I would say, more complicated mechanics, since it also contains some helpful math optimization algorithms for path planning and for kinematics. And where to learn? There are a few sources. Didn't want to put. There's a lot of sources. I don't want to put them all, but I guess good starting point would be documentation for ROS. There's a webpage called Deconstructing, and they also post some tutorials on YouTube on making robots, and they also do some math. If you type ROS in Udemy, you're gonna get some introductory robotics course. And I've chosen two, I would say, my favorite robotics channels. One is James Branton, and this is more 3D printing oriented, I would say. And recently there's a new channel called Articulated Robotics, and here you can start like getting to know the whole ecosystem from scratch by building a simple mobile robot. Yeah, so I think that's it. If there are any questions, please ask. No? Okay, then let's go have a beer.